Hello, my name is Jordan Barnes and welcome to my instructional video of inputs and outputs. Today we'll talk about what is an input, what is an output, and how they can be combined together in a system. Firstly, we'll describe what an input actually is. An input is a device which you input into a system that does transfer of energy or information. So we have our input and we have our output device, and together we're going to combine them to represent a real life situation or scenario which can be used in the environment. An example of an output would be our buzzer, which outputs a sound based on what code is written in the program. So the scenario that we're going to represent is we are going to recreate a car's parking sensor. Now, a car's parking sensor determines the distance to a nearby object when the car is in reverse and lets off a noise letting the driver know how close they are to that said object. So let's have a look at the code that we wrote to recreate this system. Let's explain the code a little bit. First of all, we have our imports. We're importing the Grove Pi, the pin, the sensors, and the pin mode, which will let us directly manipulate all of the sensors on the board. So let's explain the code a little bit. We have the class and we have the static void main, which is going to house most of our main code and an instance of the Grove Pi. Next, we need to create instances of each sensor. Here we have an instance of a ranger, and here we have an instance of a buzzer. Here it is important to note that each instance of a sensor has its own pin, which directly correlates to the pin number on the Grove Pi board. The first block of the if statement will compare the range's distance against the minimum threshold value, print out the value at, and also output the buzzer sound. The next block of the if statement will compare the range's distance against the maximum threshold. It'll print out that the car is far away, and it'll also turn the buzzer off. The last section of the if statement is when the range's distance falls in between the minimum and maximum distance of the threshold. It'll turn off the buzzer and then turn it on after half a second rest. So while something is getting closer to the ranger, it's making the buzzer go off and constantly be on. As you can see, the changes in the ranger's distance in the terminal. So to finally conclude, we are using our ultrasonic ranger as an input, our buzzer as an output, and recreating a parking sensor for a car. Thank you very much for taking your time to watch this instructional video.